At BVISD with Mrs. Miller. Today we're focusing on solutions and specifically water. So what do we want to be able to do with this? We want to be able to demonstrate the uniqueness of water as a chemical substance, model the three-dimensional geometry of water molecule, relate the physical properties of water to the molecular model of water. But before we go on and do that, we actually need to review some concepts. Or you need to check and make sure that you remember these concepts. Chapter 4, we went over the meaning of the electron dot structures. So you have to remember what the purpose of valence electrons are, what the electron dot structure, draw in your journal what the electron dot structure for phosphorus is, and what other kind of information can the electron dot structure tell us. In Chapter 9, we need to remember how to determine molecular geometry, the electronegativity, and polarity. So what determines polarity? Remember, lone pairs require more room than bonded pairs, and all angles are designed to be at the greatest possible point from each other. So how do we determine electronegativity? That's also one of your reviews. Chapter 10, we want to know the structures of solids, liquids, and gases, and the kinds of state changes and energy in state changes. So what happens to energy during state changes, basically? So let's talk again, let's refocus back on water. So how many things do you use water for every day? Well, I can think of a couple. I mean, obviously I use it for bathing, I use it for drinking. Did you know that you actually use it to go to school? So for transportation as well. Lots of things. I'm sure that you can add a couple more, and I would ask you to do so inside your listening check journal. Now, let's go on to the main hardcore stuff that we need to be focusing on. One thing that makes the Earth completely unique among the other planets in our solar system is the amount of liquid water. It covers about 75% of the Earth's surface. Now, water has actually given the Earth the nickname of the blue planet or the blue marble. Now, Mars is the only other planet that has water, but it's frozen. And although life is could be found on Mars, it hasn't been found in higher living organisms. Now, it's one of the unique properties it's water's unique properties that support life. So let's go look at those unique properties. So one of those things we know is polarity, and that makes it slightly positive and slightly negative. The slightly positive side being on that exposed proton of the hydrogen, and that slightly negative side being on the oxygen. Now, it also has some other unique properties, including that really great sort of bent structure that is created out of it. But what the other thing is that its density, when it becomes a solid, is so much lighter than its liquid phase, which is completely unusual for elements even around, or compounds that are holding around the same mass. Now, it also goes against the norms of most other chemical compounds within its mass group, and it has the melting point is much higher, and the boiling point is much higher than any other ones. So if you can take a look at the other formulas that we see down in here, you might want to take just a real quick glance at that, try to see how they're completely different. Water is also a liquid at room temperature rather than a gas, as opposed to ammonia or nitrogen or methane. So what about those intermolecular forces in that water? Well, water's dipole nature actually makes it a really attractive interparticle force. Now, so we know that water, because of that exposed proton and that negative, actually makes it want to bond with other things. So that's a really great deal. And that creates that weak hydrogen bond on that exposed proton. So oxygen, fluorine, and nitrogen really love to bond with the hydrogen. However, the electronegativity of the oxygen is just sufficient, so sufficient, that it can actually pull that little electron over to itself so much that that proton from the hydrogen becomes exposed. So another thing you need to make sure is that any molecule with an OH bond, including water, has the potential to form hydrogen bonds. And those are really important things because they are the building block of DNA and all kinds of other stuff. So you may think of water as anything, you may think of water as just being water, but because of that OH bond, it's an alcohol. So anything with an OH bond is an alcohol. So sodium hydroxide, that OH group is that alcohol. So you're going to hear a lot about function groups at some point. And one of these function groups is alcohol, which is the OH. Others that you might incur are the esters, the COOH with the R prime, meaning the COOH is the function group and the R prime is everything that comes off of it. And you might see some ketones. Now, you also have to remember that because water is an alcohol, normal alcohols, quote unquote, have similar properties to water. Now, most biological compounds contain OH bonds, like proteins, nucleic acids, like we went over, the DNA, and carbohydrates. Well, the great idea is that the polarity allows for these chains to be created to make these complex three-dimensional structures for life. Now, the other wonderful thing about water, there's a couple other things we need to look at, is that surface tension. Now, surface tension is basically a force needed to overcome the intermolecular force attractions and break through the surface of a liquid or spread the liquid out. Now, we know that water has a higher surface tension simply because if you've ever tried to jump into a pool and do that belly flop, you know that water will push back on you and it hurts. The other thing about that high surface tension is that we create something called capillary action, and that actually allows water to creep up very small or narrow tubes without actually having to be forced up it or sucked up it. This makes life possible with plants. Now, the other thing is the high specific heat. Water is a great insulator, so if you're near a large body of water, it stops you or your temperature from fluctuating too much, and it takes a lot of energy, about 4.81 joules per grams Celsius, to raise water 1 degree Celsius. So that is a really high specific heat, making it that insulator and resistant to change in temperature. Now, other thing that you need to remember is that most of the drinks that we consume are actually aqueous solutions. Our Gatorade, our tea, our coffee, anything, even our soda is mixed with water. So water is also called that super solvent. So here's your listening check. Record the answers in your journals and bring your questions to class, and we'll see you next time. Thanks.